Okay, today we are doing page 128, lesson 2-7, and we're going to look at example 1 first. We are learning more properties of integer exponents. So I think we have 3 different properties we're going over today. Actually, maybe only 1, or only 2. But we are going to look at example 1, and we're going to talk about the zero exponent property. This one is fairly simple, but I don't want you guys to get confused with it. So it says Marcella is playing a card matching game with some classmates. 4 matches have been made. It is Marcella's turn and she chooses 3 to the power of 0. What card would complete her match? So they're playing a matching game like 3 to the power of 4 is 81, 3 to the power of 2 or 3 squared is 9. So what I need to figure out is my zero exponent property and what it means when I have 3 to the power of 0. So the way I can look at it is, let's just say I have 3 to the power of 2 divided by 3 to the power of 2. We learned yesterday that if I'm dividing and I have 2 of the same exponents with the same base, actually the exponents don't even need to be the same base, I'm subtracting. So I can rewrite this 3, 2 minus 2, which equals 3 to the power of 0. 3 squared is 9, 3 to the power of 1 is 3, so 3 to the power of 0 is 1. To get there, I am dividing by 3 every time, so 81, we know 3 to the power of 4 is 81. I'm dividing by my 3 to get 27, divided by 3 to get 9, divided by 3 to get 3. 3 divided by 3 is 1. So my simplified form is 3 to the power of 0 equals 1. That is the zero exponent property. So anything to the power of 0 is always 1, as long as a is not 0. So I want you guys to do your try it. This should only take you a few seconds. Okay, now let's look back. -7 to the power of 0. Anything to the power of 0 is 1. So I get 1, 1, 1, 1. So now my final answer is 7 to the power of 0 is 1. 43 to the power of 0, 1. 1 to the power of 0, 1. 5/10 to the power of 0, 1. That is my zero exponent property. Pretty simple, pretty self-explanatory, that anything to the power of 0 is just 1. Okay, let's look at example 2. So we're doing the negative exponent property. So now we're going to look at if my exponents end up being negative, what do I get? So if I have 4 to the power of 3 divided by 4 to the power of 5, I can rewrite this. 4 to the power of 3 is 4 times 4 times 4. I have 3 4s. Divided by 4 to the power of 5, I have 5 4s. 1, 2, 3, 4, 5. Now, first of all, I can cross out anything that they all have in common. Now I'm left with 4 times 4 here and nothing here. So I remember that 4 divided by 4 is always 1. So I'm technically have a 1 up here divided by 4 times 4. So 1 divided by 4 times 4 is 1 over 16. So my final answer is for 4 to the power of 3 divided by 4 to the power of 5 is 1 over 16, or 1/16. I also could have done this by looking at what my exponents were. So 4 to the power of 3 divided by 4 to the power of 5. Remember what we just did in this example. When I have the same base, I can subtract my exponents. My bases are the same. So I have 4, and then 3 minus 5 is -2. This is where my negative exponent is coming into play. So the negative exponent property states that anytime I have something like 4 to the power of -2, I would have that is 1 over whatever 4 to the power of 2 is. So that negative is telling me that I am going to be working with a fraction, and then 4 to the power of -2, 4 to the power of 2 is 16. I hope that is making sense, but I'm going to do one more just to make sure. So let's do 5 to the power of 3 divided by 5 to the power of 4. So based off of my negative exponent rule, I can already use my quotients of power property and do 5 and then 3 minus 4, because my bases are the same and it's division, I can subtract them. I then get 5 to the power of 1. Now I'm thinking not positive 1, negative 1. Now I'm thinking, what is the power? 5 to the power of 1. That negative is telling me my 1, it's going to be 1 over something. 5 to the power of 1 is always its number, so its base is 5. So my final answer would be 1/5. I now want you guys to answer the triads A, B, and C, and then we'll come back and get to the answer. Okay, let's look at A. So I know because I have a negative exponent, it's going to be 1 over something, and then 8 to the power of 2 is 64. So I get 1 over 64. Now I'm going to do 2 to the power of negative 4. I know it's going to be 1 over something. So I do 2 to the power of 4, which is also 2 times 2 times 2 times 2. If I want to simplify it this way, 2 times 2 is 4 times 2 times 2. That gives me 8 times 2, and I get 16. So I know 2 to the power of negative 4 is 1/16. And last but not least, I'm doing 3 to the power of negative 5. So when I'm doing 3 to the power of negative 5, I need to write it as 1 over something. I'm writing it as 1 over something because I know that that is a negative exponent. So my fraction is going to be over 1. So then I'm going to do 1 over, and then 3 to the power of 5 gives me 3 times 3 times 3 times 3 times 3, which is 3 times 3 is 9 times 3 times 3 times 3. 3 times 9 is 27 times 3 times 3. Wow, I should have gotten a calculator for this one. 27 times 3 is... Hold on, let me try and get a calculator. You guys probably just type this into your calculator. I'm trying to do this in my head. 27 times 3 gives me 81. Oopsies. 81, and then 81 times 3. Wow, I cannot do this now apparently. 81 times 3 gives me my final answer of 243. So it would be 1 over 243. Does this make sense? If you have questions about this, hopefully I was able to show it, but if not, send me an email and I can help. And then finally, let's look at example 3, expressions with negative exponents. So now I have the expression 1 over 7 to the power of 3. So first of all, I want to use my negative exponent property, which is what we just did. And we know we can leave this, if I look up here, I could have left this as 1 and 3 to the power of 5. Or we could have figured out what 3 to the power of 5 was. So over here, I just want to leave it. I mean, I can have, and I can do 7 to the power of 3 and then have 1 over 1 over 7 to the power of 3, which is, I really needed my calculator, times 7 times 7, which gives me 343. But I don't even want us to do this step. I just want to leave it as 1 over 7 to the third. Now, if I rewrite this, this is basically saying 1 divided by 1 over 7 to the power of 3. If I'm dividing, remember, I'm finding the reciprocal, so I can do 1 times 7 to the power of 3 over 1. 1 times 7 to the power of 3 is 7 to the power of 3. 1 times 1 is 1. So I get my final answer of 7 to the power of 3. I hope this makes sense. We also could have said, let me see if I have enough space. I will accept either answer. We could have done 1 over 7 to the power of negative 3 and then done our 1 over 343 and then rewritten it as 1 divided by 1 over 343 and then found the reciprocal, which is 1 times 343 over 1. Put that over 1 and I could have gotten a final answer of 343. 7 to the power of 3 is the same thing as 343, so those are equal. I now want you to do your try-its, A and B. Okay, so I have 1 over 5 to the power of negative 3. I can rewrite this as 1 over 5 to the power of 3. And then this, if I want to write it as division, 5/3, and then find the reciprocal, not 5/3, sorry, 5 to the power of 3. 1 times 5/3 over 1, which gives me 5. Why do I keep saying thirds? Which gives me 5 to the power of 3. Or you could have done 5 to the power of 3 and you could have just solved that and known 5 to the power of 3 was 125. I will accept each answer. And then finally, let's do this one. I have 1 over 2 to the power of negative 6. I can rewrite that by saying 1 over 1. Oops, I wrote that one a little big. 1 over 1 over 2 to the power of 6. Remember, we're getting this because we found out using our negative exponent property that I can rewrite this as 1 over whatever my power is. So then I have 1 to the power of 2 over 3. Rewrite that as a division statement. I think I said 2 to the power of 3. Don't listen to me. Look at what's on my paper, 2 to the power of 6. And then I'm using my reciprocal, 1 times 2/6 over 1. 1 times 2/6 is 2/6 over 1, which gives me the final answer of 2/6. And then if we were trying to figure out what that was, if you put it into real numbers, instead of leaving it in exponent form, you would have gotten 64. I hope this is making sense with our exponent properties. I will have you guys solve. I want you to do, flip to the back, 5, A and B. And then I want you to do 7, 10, and I think I have one more written down, but I don't remember what it was. Oh, it was 15. I just looked at my sticky notes. So I want you guys to solve 5, A and B, 7, 10, 15. And then when you are done with this, you are going to staple it and turn it into the tray. Please do not forget to put your name on it so that I can grade it. Just a heads up, tomorrow we will be doing a real numbers vocabulary quiz, and then we will continue with exponent properties and their rules. Have a great day, and I will talk to you all tomorrow.